Hello, welcome. Let's try to solve another liquid problem 3239. Minimum number of flips to make binary grid palindromic 1. So for this problem, we are given m times n binary matrix, and a row or column is considered palindromic if its value read the same forward and backward. So for example, 101, so this is a palindromic. For this row, and for this column 101, it is also palindromic. So this is just the meaning. But from the beginning, we are given this kind of grid. It is not palindromic. And we can flip any number of cells in grid from 0 to 1 or from 1 to 0. So we're going to return the minimum number of cells that need to be flipped to make either all rows palindromic or all columns palindromic. So what we can do? So the brute force idea is that we're going to check row by row and column by column, and we're going to check the minimum steps. And for each of the row, it is independent. So for example, for the first row, it is 1 0 0, and for the second row, it is 0 0 0. So for the second row, it doesn't matter because it is palindromic itself. But for the first row, it is not. But how can we check that? So we're going to check it according to the brute force. We're going to check from the middle point. So this is a 0, it is okay, and this one is not equal to this is 0, so we're going to count it as 1. And similarly for the columns, we're going to just check out the column by column and row by row, and we're going to check what is going to be the minimum. So this is going to be the brute force idea. So we're going to write help function, so we're going to call it check. So inside it's going to be an array, and we're going to check the length of the array. So if the length of the array is odd, so for example if it equals to 1, so we're going to prepare the left and the right pointer, because we are going to check what is going to be the minimum flips. So it's going to be n divided by 2 and n divided by 2. So in this example, the length of the row going to be 3 divided by 2, it is 1. So the left and the right are going to be 1. So else, so if it is even, so L and R are going to equal to n divided by 2 minus 1 and n divided by 2. So the idea is if there are 4 columns. Yeah, so for the first row, there are going to be 4 columns. So what's going to happen? N divided by 2, it is 2, 2 minus 1, it is 1. So for example, 4 columns, 1, 1, 0, 0. So this is a left pointer, and this is a right pointer. So we just need to find the left and the right pointer. And then left pointer going to go to the left, and the right pointer going to go to the right. And we're going to check one by one, and we're going to check how many flips. And basically, this is the idea, how to count how many flips. Now we're going to use a while loop. So the left pointer going to more than equal to 0, and the right pointer going to be less than n. So we're going to check if a L are not equal to a R. So this means this means basically we need to have a flip. So we're going to use a result plus 1, and then we're going to update this L and R, and we're going to return the result. So we're going to put the result here to be 0 from the beginning. Yeah. So this is just a check function which is going to help us count how many of them. Yeah. Now let's just use a result going to equal to 0, and we're going to check row by row. So for row inside the grid. Yeah. So for each row inside the grid, we're going to count how many of them, and we're going to use the result plus equal to the check function, and inside it's going to be the row. Yeah. And similarly, we're going to use an answer equal to 0. We're going to check the column, right? Yeah. But for checking each of the column, right, we need to check the first column, and then the second column, then the third column, like that. Yeah. So basically, we need to know how many columns we're going to check. So this means for say in raised columns, it's going to be the length of the grid 0. So this means we're going to check how many columns. And for each of the column, we need to get a column array. So this is going to be the column array. It's going to be the inside it's going to be an array. Inside it's going to be a grid with R and say, so for r in range length of the grid, yeah, length of the grid. So this means we're gonna check all the rows, and for each of the row we're gonna take out the first index, so the index is gonna be say. So this means it's gonna be the first column, and then it's gonna be the second column, and then it's gonna be the third column. So for each of the column we're gonna count how many of them, how many of the flips. So answer gonna plus equal to the tag with the column. And finally, we're gonna return the minimum of the row and column, result and answer. Yeah. So this is gonna be the entire solution. As you can see, this is not a hard problem. Everything gonna be just a easy one, like how to tag and how to count row and column. Yeah. Now let me just run it to have a check. Now as you can see, it works. Now let me submit it to prove that it can pass. Yeah, now as you can see, it passed for all testing cases. And now let's analyze the time complexity. So for here, this is the row, and for each of the row, we're gonna use a check function. So for each of the row, we're gonna check all of them. So this means basically the time complexity is gonna be m times n. And similarly for here, the time complexity going to be m times n. So m times n going to be 2 times 10 to the power 5. That is why it's so fast. So I think that's all about it. Thank you for watching. See you next time.